So what were we discussing yesterday?
The basics of a microprocessor and the system buses.
Okay, let me see how many of you were actually paying attention yesterday. Mm, Rubin, Rubin Gala, are you there?
Yes, ma'am.
Rubin, what are the three types of buses?
Ma'am, address bus
Hmm.
uh, and data bus and control bus.
Okay, very good. Mm, then Abhishek, tell me what do you mean by what are the various components in a microprocessor based system? The major units in a
Ma'am,
microprocessor based system.
ALU and control unit, ALU control unit, and ma'am, left hand and right hand side there are input and output devices, and in lower order there are memory unit.
Okay. Mm, what is meant by memory unit with respect to 8085 and 8086?
Ma'am,
Shresh Gupta, in relation to 8085 and 8086, when I say memory, what is meant by that? Which memory am I talking about? Shreyash Gupta, roll number 57. No? Shreyash, are you there or should I mark you absent? No. Mansi Gupta,
Yes, ma'am.
when I say memory in relation to 8085 and 8086, which memory am I talking about?
Ma'am, primary memory.
Why? Why primary memory?
Ma'am, because it was invented very early, like 8085 and 8086. So at that time, secondary memory was not uh, in existence.
Okay, good, good. That means you people are listening. Okay, what else did we discuss yesterday? Okay, now we discussed the components of a microprocessor based system. Then we discussed the three types of buses. And then we also
Excuse me,
discussed
ma'am.
how does a microprocessor work, right? Okay. Now, Vaishnavi, tell me what are the three stages in the working of a microprocessor?
Fetch,
Hmm.
NQ, and DQ.
Hmm.
Fetch,
NQ,
DQ, NQ, DQ, NQ. Decode, NQ.
fetch, decode, and not NQ.
NQ.
E is not for NQ. After fetching and decoding, what do you do with the instruction?
Decode.
After fetching, you decode it. After decoding it, what do you do with the instruction?
NQ it, no?
इंस्ट्रक्शन को
Execute.
आप कर क्या सकते हो क्या करते हो
Ma'am,
And
इंस्ट्रक्शन
execute.
एग्जीक्यूटेड
execute. Oh, sorry, execute.
एग्जीक्यूटेड हाँ एनक्यू डीक्यू सब स्टैक में होता है
Uh,
हाँ fetch decode and execute
execute.
okay somebody tell me what is meant by fetching साहिल चोडिया tell me what is meant by fetching क्या fetch करते हैं और क्यों fetch करते हैं साहिल चोडिया if you stay mum now, I'll note it down somewhere. I'll mark these people absent if you don't respond. And don't tell me, give me the excuses that my audio is not working and all. Sahil Chodia. Okay. That means, see, these all will reflect how you know, how your term work marks would be, how you are responding, how you are answering, your Viva marks. Huh? Because right now our sessions are going online. So there is no other way to examine your performance. Okay, Venus, tell me what do you mean by fetching? Venus bias. Roll number 8, Venus, unmute yourself and tell me what do you mean by fetching? Venus, tell me what do you mean by fetching? What do you fetch?
Fetching data.
सिर्फ डेटा और कुछ फेच नहीं कर सकते? Data and instructions. Because why do we need to fetch? Because where is data and instruction stored?
सॉफ्टवेयर में रहता है, हार्डवेयर में रहता है वो.
Where are data and instructions stored in a computer? In the
Memory.
memory. In the memory. So where are they going to get executed? Where are they going to get executed? Inside the कोई और बोलो. Where are instructions executed? Inside the
microprocessor.
at the microprocessor. So your data and instructions are there in the memory. They will get executed in the processor. So you have to bring them from the memory to the processor. That is what is meant by fetching, right? Now, who will tell me what is meant by decoding? Wait. Saharsh Gadodia. Saharsh, tell me what do you mean by decoding?
Ma'am, it identifies the instructions to be executed.
Identifies the instruction means it understands, interprets from the instruction what is to be done.
Yes,
Right?
ma'am.
That is called as decoding. So once the instructions are fetched sequentially from the memory, instructions are stored sequentially in the memory, they'll be fetched one by one, decoded, and then executed on the microprocessor, right? So this
Yes,
is
ma'am.
how NUP works. This was what we were discussing yesterday. Now we'll proceed with today's agenda,
Excuse me, ma'am.
which is features of a 8086 microprocessor and then architecture of 8086 microprocessor. Okay, so these 2 points we'll be covering today. We'll begin today.
Ma'am,
Yes.
ma'am, yesterday actually gave an example explaining the address and the control buses, how they actually work. So ma'am, could you please explain it once more?
Who is talking?
Ma'am, Aditya.
Bosley.
Yes, ma'am.
Okay. Aditya, see, when you have some data stored in the, if you see, you can do both read and write operations, right?
Yes,
So
ma'am.
suppose you want to access a particular memory location, say, memory is nothing but a series of locations and every location will have an address of its own. How do you identify a location? By its address. So if you have an address 3500, and then you have some data which is stored there, say 45. Okay, and you want to read that data, say 45. So then how will the buses be used in the process? That was what we discussed yesterday. So what?
Yes, ma'am.
So first you have to place the address 3500 on the address bus, because that is the location that we want to access. So first you will place that address which you want to access on the address bus. And then if it is a read operation, the control bus should have that read signal. A read signal will be generated by the control unit, and that will be a signal will be there on the control bus. Then you will access that, you will go and access that location. Okay. Now if you want to move it, if you want to copy it to the microprocessor, then that will be done via the data bus. Now if it is a write operation that you want to perform, then again, say you want to write some data, say 100 in location 4000. Again, what will be the procedure? You will write 4000 will be put on the address bus. Then the data that you want to write over there will be put on the data bus. And then your control bus will have a write signal in it. So then that data 100 will get written into that location 4000. This was what I told yesterday.
Okay,
Is it
ma'am. So
clear?
that means the actual operation that is to be done, be it either read or write, the actual operation is done by the control bus.
No operation is done by the control bus. It just carries the signal, whether it's a read operation
Okay.
or a write operation.
Okay.
Okay. Simple. Address bus carries the address, data bus carries data, and control bus carries the control signals. There are several other control signals also apart from read and write. Read and write are the basic operations that we normally do on memory locations. Okay. Now moving on to the very first topic in your syllabus, which is features of 8086. Okay. 8086 was introduced in March 1978. Okay, so you don't have to by heart the date and all, but that is the approximate time around which 8086 was introduced. That's the very first point. 8086 is a 16-bit microprocessor which is implemented using high density metal oxide. It's semiconductor technology. Okay, HMOS means high density metal oxide semiconductor technology. A different technology using which microprocessors are manufactured. So HMOS is one of the technologies. So 8086 is a 16-bit high density metal oxide microprocessor implemented with 29,000 transistors. Okay. It can be operated with a clock frequency of 5 megahertz. So this is one point which you have to remember. The clock frequency at which this chip is operated is 5 megahertz. So number of pins is 40, technology is HMOS, clock frequency is 5 megahertz. Okay, these are some basic features regarding the hardware part. Now, coming to the important features on which we have to focus. It has a 20-bit address line and hence it can address 2 power 20, which is equal to 1 MB memory location. Okay, keep this point in your mind. 8086 is a 16-bit MIPI. Okay, so that means the data bus, the size of the data bus is 16-bit. It can access 16-bit bits in one clock cycle. So 8086 is a 16-bit microprocessor. 16-bit microprocessor means we are talking about the size of the data bus. Coming to the size of the address bus, the size of the address bus is how much? 8086 has 20-bit address lines. So 20-bit address lines means it can access 2 power 20 memory locations. 2 power 20 is nothing but 1 megabyte memory location. So that means 8086 can address 1 MB memory locations. Okay. So can somebody tell me if 8086 can address 1 MB memory location, then what would be the range of memory address? Can somebody tell me what is the range of memory address if 8086 can access 1 MB memory location? It can access 1 MB memory. So what would be the range of memory addresses? Does anybody know to calculate the range of memory address?
I'm raised to 2. Raised to
8086 can access 2 power 20 memory locations. So what would be the starting address and what would be the ending address? That is what I'm asking. What would be the address of the very first location? What would be the address of the very last location?
Ma'am, the address range will start from 0000H and it will end at FFFFH.
0000 and FFFF. नहीं है. 2 power 20 memory locations. You are close, but not right. It's not right.
No,
Aditya
5
is
zeros
very
and 5
close to
Fs.
the how many?
5 zeros and 5 Fs.
5 zeros and 5 Fs. Okay, 5 zeros and 5 Fs. Do you all know how Aditya gave this answer? Aditya is saying the range of memory address is from 00000 to FFFFFH. Now, those who are wondering how this came about, how did this come about? Does anybody know the answer? Aditya said this is the range of memory addresses. If 8086 can access 2 power 20 or 1 MB memory location, then this is going to be the starting address and this is going to be the ending address. So in between you have so many series of locations which you can access. Like this 00001, etc., etc., FFFFFH. How did you get this range? Can anybody explain? Do you know the hexadecimal system? In DLCA, you might have learned the decimal number system, hexadecimal number system, conversions and all. So then you should be able to answer. How did we get this range of addresses? Come on. ये सब हो गया है DLCA में last semester.
मैम 1024 kilobyte to 1 MB 2 raised to 20.
ये एड्रेस कैसे आया मैं पूछ रही हूँ. Number system. I hope everybody is familiar with the powers of 2. Powers of 2 सबको पता है?
Yes, ma'am.
What is 2 power 1? What is 2 power 1?
2.
2.
2.
2 power 2? 4.
4.
पहले ये पढ़ते हैं. 2 power 8? 2 power 8?
256.
256. 2 power 9?
5 and 2.
5 and 2. 2 power 10?
1024.
1024.
1024. This is also equal to something. This is
One.
also equal to 1
Kilobyte.
1K.
1 KB.
Right?
1 KB.
What is 2 power 11? How many Ks? 2 power 11 is how many Ks?
2K.
2K.
2K, right? This is because this is 2 into 2 power 10, which is equal to 2K. So now you tell me what is 2 power 15? How many Ks? 2 power 15 is how many Ks? Very
32.
good. 32.
32.
How did you get 32? It is 2 power 5 into 2 power 10, right? So it is 32K. Okay. So what is 2 power 20? 2 power 20 is
1024.
2 power
1024.
2 power 10 into 2 power 10. That means it is 1K into 1K. So 1K into 1K is nothing but 1 MB, mega. That is why I told 8086 can access 1 megabyte of memory. How many address lines does 8086 have? How many address lines 8086 has? 20 bit
20.
addresses. That means it can access 2 power 20 memory locations. 2 power 20 memory location means what? It's 1K into 1K, which is equal to 1 megabyte. That is why I told 8086 can access 1 megabyte of memory. Okay. Now, let's learn a little further also, because this is all these terminologies you will be using in the subject, throughout the subject. Now you tell me what is 2 power 24? What is 2 power 24? 2 power 24?
16 MB.
16 MB.
16 MB. Okay. So what is 2 power 30?
1 gigabyte.
1 gigabyte, right? So it is 2 power 10 into 2 power 20. So it is what? It is 1K into 1 kilo into 1 mega. 1 kilo into 1 mega is nothing but 1 giga. So always understand, when you multiply something with 1K, it goes to the next level. 1K into 1K is 1 mega. 1K into 1 mega is 1 giga. So now you tell me, what is 2 power 40? What is 2 power 40?
1 tera.
1
tera. So how do
terabyte.
you get that? 2 power 10 into 2 power 30. What is 2 power 10? 1 kilo. 1 kilo into 1
1
giga.
G.
1 kilo into 1 giga is what? 1 terabyte. 1 terabyte of memory. So you keep this in your mind forever. Okay. 2 power 20 is nothing but 1 megabyte. 2 power 30 is nothing but 1 gigabyte. And 2 power 40 is nothing but 1 terabyte. So whenever you are multiplying with 1K, it goes to the next level. 1K into 1K is 1 megabyte. 1K into 1 megabyte is 1 gigabyte. And 1K into 1 giga is 1 terabyte. So since 8086 has 20 address lines, it means it can access 2 power 20 address locations. That means it can access 1 megabyte of memory. And then Aditya told that the address ranges from 0000 to FFFFFH. Now you take 2 minutes and find out how you got this address range from 000000 to FFFFFH. Okay, I'll give you 2 minutes. I'll be back in 2 minutes. By the time you should give me the answer how we got the address range, because these are things which you already know. You've learned this in DLCA. Okay, मिला किसी को आंसर? Did anybody find out how we got this? No? Come on, 58 लोग हो आप. किसी एक ने भी find out नहीं किया? How did we get that? That means I should explain, right? Shall I? मेरी आवाज आ रही है ना?
Yes, ma'am.
That means you don't know. ठीक है. तो अभी देखो. In your computer, everything is in binary, you know. So always keep this point in mind. When you say binary in a computer, it is not the binary equivalent of your decimal number system. It is the binary equivalent of which number system? Which number system? Hexadecimal number system. Inside your computers, when things are represented in binary, it is not the binary equivalent of your decimal number system. Always keep in mind, it is the binary equivalent of hexadecimal number system. Okay. So how many digits are there in your binary number system? 0, 1, 2. आगे बोलो, कहाँ से कहाँ तक है बाइनरी डेसिमल नंबर सिस्टम में?
3 4
How many? 4
5
5
6
7 8
9.
and 9. इतना ही है ना डेसिमल नंबर सिस्टम में, from 0 to 9. So if I want to represent 0 to 9 in binary, how many digits will I require?
10.
0 to 4 करना है तो how will I do? 0 0 0 1 1 0 1 1, है ना? 2 ही डिजिट चाहिए. 0 to 7 करना है तो हम मुझे कितने डिजिट चाहिए? 3. अगर मुझे 0 to 9 करना है तो कितने डिजिट चाहिए?
4.
4. right? So this will be represented as 0, 0, 0, 0. This as 0, 0, 0, 1, 0, 0, 1, 0, and so on. What will be the equivalent of 0 or 9? What will be the equivalent of 9?
1001
1, 0, 0.
10001.
राइट ओके तो मतलब 4 है तो कितने नंबर्स आएंगे 4 if I'm using 4 digits then it is what how many numbers will be there 2 power 4 is how much 16 right out of which we have representations for 9 only in decimal so then what about the remaining digits you cannot leave them just like that they need to have some representation, right? That is why we went for which system? We went for the
Hexadecimal.
hexadecimal system because अगर 4 digits हम use कर रहे हैं तो 16 numbers आएंगे और decimal number system में तो 9 तक का ही representation है बाकी को आप ऐसे छोड़ नहीं सकते हो they should be given they cannot be invalid they should be given some representation that is why we went for the hexadecimal number system. So 0A, 0B, 0C, 0D, 0E
F.
and 0F, right? तो हो गया 16 अभी तो मतलब अगर मुझे एक 8-bit नंबर रिप्रेजेंट करना है if I want to represent an 8-bit number then my range will go from 0
0 to 7.
not 7 0 0 if I want to represent an 8-bit number my range will go from 0 0 to
Is
what? F of h right see this 0 is not 1 0 this 0 is how many 0 the 0 is this 0 is actually 4 zeros this 0 is actually 4 zeros so this is an 8-bit number right this is an 8-bit number so that means my range will go from where to where 0 0 to last का जो क्या आएगा last का क्या आएगा all ones right all ones so if I want to represent an 8-bit number then my range will go from 0 0 to f of h बराबर
Yes, ma'am.
बराबर yes or no
Yes, ma'am.
Yes, ma'am.
so if I want to represent a 16-bit number if I want to represent a 16-bit number then what will be my range
4 times 0 to 4 times f.
4 times 0 to 4 times f this will be my range that means ये देखो ये 0 1 0 नहीं है it is this to this so if I want to represent a 20-bit number what will my range go from what will my
5
range
times
go
0
from
to 5 times f.
5 times
0 to
0
5 times f.
5 times
F.
f h so that is why I said if 8086 has 20-bit address lines it can access 1 megabyte of memory and its address will range from 000h to FFFFFH देखो अगर आपको 4-bit नंबर रिप्रेजेंट करना है तो रेंज कहां से कहां जाएगा if you are representing a 4-bit number your range will go from 0 to f दिख रहा है ना यहाँ 4-bit नंबर अगर आपको रिप्रेजेंट करना है तो आपका रेंज कहां से कहां जाएगा 0 0 0 0 to the last one will be what 1 1 1 1 मतलब f बराबर this is a b c d e f this is a b c d e f what is f is 1 1 1 1 correct now so if you want to represent a 4-bit number your range will go from 0 to f if you want to represent an 8-bit number your range will go from 0 0 to f of h if you want to represent a 16-bit number your range will go from 0 0 0 0 to f of h and
Ma'am, what is h?
h is hexadecimal that
Okay.
need not be written that is understood okay h means hexadecimal And if you want to represent a 20-bit number, your range will go from 0000 to FFFFFFH. अब दिख रहा है ना, here we are representing a 4-bit number. तो 4-bit number मतलब आपका range कहाँ से कहाँ जा रहा है? 0 to F. 4 zeros means it's 0. 4 ones means it is F. So your range is going from 0 to F for a 4-bit number. 8-bit number है तो ऐसा 00 to FFFH. Just a minute. Sorry for the interruption. So for a 20-bit number, the address ranges from 00000 to FFFFH. Now the question is, why hexadecimal? Why we are going for hexadecimal? So I'll give you the reason for that also. What is the largest number that we can represent using decimal number system? What is the largest number which you can represent, largest 4-bit number you can represent using decimal number system? What is the
9.
largest?
9999.
9999, right? This is the largest 4-bit number which you can represent using hexadecimal number system. What is the largest 4-bit number which you can represent using hexadecimal number system? 4 times FFFF, right? This one. What is the equivalent of this? What is the decimal equivalent of this? What is the decimal?
15.
65536. This is the decimal equivalent of this FFFFH. So you can see the magnitude of increase. The largest 4-bit number that you can represent in decimal system is 9999. Whereas the largest 4-bit number that you can represent using hexadecimal number system is 65536. Look at the magnitude of increase which is there here. See, if somebody says tells you are going to get a 4-digit salary, which number system would you prefer?
Hexa.
Obviously hexadecimal, right? Because if you are using a decimal number system, then your salary would only be 9,999 rupees. But in case if you are getting a 4-digit salary in hexadecimal system, look at the scale of increase in your salary. And that is the reason why we are using hexadecimal number system inside the computer. Okay? Because we are able to represent a larger range of, yes.
Then why stop at hexadecimal? Like you can go much more higher. 32 base system.
But there are other restrictions also, right? The representation depends upon the internal representation that your processor can also accommodate, right? We have this IEEE 754 floating point representation format. So we cannot just see, it is just like, see, we told now, just simply by increasing the number of lines, we can increase the performance of our computer. But we cannot just go on increasing the number of lines in a computer, because then there is that cost and size trade-off. Similarly, here you cannot just go on increasing the number system, because then there are other trade-offs which are involved. There are representation formats which come into the picture. Okay?
Thank you, ma'am.
So the point is that when we use the hexadecimal number system, what we are doing is we are replacing every 4 group of binary digits by a single hexadecimal digit, right? So what we are doing is actually we are abbreviating lengthy binary numbers. Correct? So hexadecimal number system enables us to record numbers using substantially fewer number of digits than that is required in binary number system. So that is one advantage. Then readability is another advantage. But the question is why we have converted binary to hex only and not to decimal, octal or any other number system. So the answer is that Hex is the one which can be easily converted with least amount of overhead on hardware as well as software. So that is the reason why we are using addresses as hex. But internally, they are used as binary only. Okay. So you can see here, we are able to represent 65536 using FFFF, just 4 digits in hexadecimal. Right. So the point that I've made here is that inside the computer, when we say binary, it is not the binary equivalent of your decimal number system. It is the binary equivalent of the hexadecimal number system. So 8086 has a 20-bit address line. So 20-bit address line means it can address 1 megabyte of memory, and if it can address 1 megabyte of memory, then the address range is from 0000H to FFFFH. Okay, 5 times F. So we have discussed few features till now. One is 8086 was introduced in 1978. It uses high metal oxide, high density metal oxide semiconductor technology. Number of pins is 40. 8086 is a 16-bit MUPI. That means the size of the data bus is 16-bit and the size of the address bus is 20-bit. Okay. Size of data bus is 16-bit means it can access 16 bits in one clock cycle. If you say for 8085, the size of the data bus is 8-bit. That means it can access 8-bit data in one clock cycle. Okay. Then coming to the next point, 8086 can be operated in 2 modes, that is minimum mode and maximum mode. What do you mean by minimum mode and maximum mode? We'll be learning in detail about this minimum and maximum modes. This one, okay, I'm talking about this point. 8086 has 2 operating modes, minimum mode and maximum mode. If you say 8086 is in minimum mode, then it means 8086 is the only processor in the system. That means it is there in uniprocessor configuration mode. 8086 is the only processor in the system. If you say 8086 is in the maximum mode, then it means along with 8086, you have interfaced other co-processors also. You want to do some additional operations, so you have interfaced other co-processors. That means 8086 is not the only processor. There are other processors. That means multi-processor configuration. So 8086 can operate in 2 modes. Minimum mode is the uniprocessor configuration. 8086 will be the only processor in that configuration. Maximum mode means along with 8086, you will be having other co-processors. That means it is multi-processor configuration. Okay, we'll be learning in detail about this point in the coming sessions. Coming to the next point, 8086 has 2-stage pipelined architecture. Now tell me what is meant by pipelining. Do you all know what is meant by pipelining? I think this was there in digital DLCA.
Ma'am, it is a process where while executing the current instruction, the processor is fetching the next one.
Okay, why do we do that?
Ma'am, to make the process
To
more
save
efficient.
time.
Pardon?
To make the process more efficient.
Yes, to increase the performance of your computer. So 8086 has a 2-stage pipelined architecture. What is meant by pipelining? Pipelining is one of the technique to increase the performance of your computer. Whatever performance that you are enjoying now is because of, is one of the reason is because of the pipelined architecture of your processor. So what is pipelining? Pipelining is a property where you exploit the parallelism which is there in your parallelism, the property of parallelism in your processor. What do you mean by parallelism? See, in pipelining, when you are executing the current instruction, you will fetch the next instruction to be executed. Now, why is that done? Does anybody know the reason how that is done or why that is done? किसी को पता है? Why is that done? Any idea? We'll come to this. I'll make it clear with an example, okay? What you see in front of you is a task, okay? There are 4 bundles of laundry which is to be done. And then there are 3 subtasks in that, okay? First is you have to wash that. Second thing is you have to dry that. And then third thing is that you have to fold it, okay? So washing, drying and folding. So there is a person who has to do 4 bundles of laundry where washing takes 30 minutes, drying takes 40 minutes and folding takes 20 minutes. So if he is doing this sequentially and if he's starting his work at 6 p.m., by what time will he end his job? By what time will these 4 laundry bags get done? What time? See, 30 minutes for washing, 40 minutes for drying and 20 minutes for folding. So he's starting at 6 p.m. So that means by 6:30 he'll complete washing. Then after another 40 minutes he'll complete drying, and then after another 20 minutes he'll complete folding of the first laundry bag A. Same thing he has to repeat for the laundry bag B, C and D. That means around midnight he'll complete his job. This is the normal scenario where pipelining is not involved. Now suppose he is doing pipelining, he is using the concept of pipelining. What will happen? What will happen? See, first 30 minutes, he's starting with the laundry bag A, he's washing. In the next 40 minutes, he is drying the first bag, right? Now at that time, when he is drying the first laundry bag, is the washer free or not? Is the washing machine free or not? Yes, right. The washing machine is free. That means instead of keeping the washing machine idle, he can just go on and wash the second bundle, right? Similarly, when he is folding the dresses in the first laundry bag, the dryer is again idle. So he can make use of that dryer also by parallelly bringing in the next bundle. So this is what is called pipelining. So what is happening here? We are not letting any resource to be idle. We are not letting any resource to be idle. The same concept can be applied in a processor also. Whereas who is doing the fetching? Who is fetching our instructions? Which resource is being used when we are fetching instructions? Fetching का काम कौन कर रहा है? Processor में. Bus कर रहा है, right? When you're fetching an instruction, bus is doing that job. Where is execution happening? Processor में. So you have bus, you have the processor. Fetching is done by the bus, execution is being done by the processor. तो समझो आपने एक इंस्ट्रक्शन फेच किया और उसको बाद में एग्जीक्यूशन के लिए डाल दिया प्रोसेसर में, तो वो टाइम पे अपना बस फ्री है कि नहीं? बस फ्री है कि नहीं?
Yes, ma'am.
So why to let the bus free? We can fetch the next instruction which is to be executed. This is what is called as pipelining. Okay, and this is one of the reasons, one of the factors using which we can increase the performance of our computer drastically. See, there are other ways also to increase the performance. One is, I told you can increase the number of number of data lines in your computer. So 8-bit data bus hai to 8-bit can be transferred in one clock cycle. 16-bit data bus hai to 16 bits can be transferred in one clock cycle. 64-bit hai to one clock cycle mein you can transfer 64-bit. But we cannot just go on increasing that, because that will indirectly affect the size of our computer also. Because increasing the number of data lines means the size of your system will also increase. So there is a trade-off. That is one way you can increase the performance. Another way you can increase the performance is by increasing the clock frequency. But clock frequency भी मतलब Pentium से हमारा data bus का size भी almost constant रहा है. From Pentium we are using this 64 bit size. So जो peak value है वो Pentium से we have reached that peak value. From there on we are using that constant data bus size. Clock frequency भी Pentium से almost constant ही है, 3.2, 3.4, 3.6 clock frequency पे चल रहा है हमारा. Okay, so those are two ways in which you can increase the performance. And the third way is pipelining. There are other technologies also using which you can increase the performance, but pipelining is one way in which you can increase the performance of your computer. So 80, what we were talking is 8086 has a two-stage pipeline architecture. Now, what do you mean by two-stage pipelining? Let me make it clear with this diagram. Okay. यहाँ पे 3 स्टेज दिखाया है, but actually 8086 has 2 stages only. Fetching and decoding and executing is considered as one phase. So you know that 8085 has a non-pipelined architecture. 8085 has a non-pipelined architecture मतलब क्या? मुझे अगर 3 इंस्ट्रक्शन एग्जीक्यूट करना है और अगर 3 स्टेप है, fetch, decode, execute. So if I want to execute 3 instructions in 8085, how many clock cycles I'll require? Every instruction requires 3 clock cycle. One clock cycle for fetching, 1 clock cycle for decoding, 1 clock cycle for executing. तो instruction 1 के लिए 3 clock cycle हो गया. वैसे instruction 2 के लिए 3 clock cycle और instruction 3 के लिए 3 clock cycle. मतलब total अगर pipelining नहीं है तो मुझे 8085 में to execute 3 instructions, how many clock cycle I will require? How many clock cycles I will require in 8085 to execute 3 instructions?
9.
9 cycles. But समझो pipelining है, 8086 में pipelining है, तो pipelining है मतलब मुझे 3 instruction execute करने के लिए कितने clock cycles लगेगा? 5. देखो यहाँ पे 5th clock cycle में आपका 3rd instruction execute होके खत्म हो गया. देखो फर्स्ट इंस्ट्रक्शन 3 क्लॉक साइकिल में हो रहा है, फैच, डिकोड, एग्जीक्यूट 3 क्लॉक साइकिल में हो गया. सेकेंड इंस्ट्रक्शन यहाँ पे शुरू हो रहा है, फैच, डिकोड, एग्जीक्यूट मतलब 4th क्लॉक साइकिल में सेकेंड इंस्ट्रक्शन हो गया. यहाँ पे देखो ये 3rd इंस्ट्रक्शन है, फैच, डिकोड, एग्जीक्यूट. 5th क्लॉक साइकिल में 3rd इंस्ट्रक्शन का एग्जीक्यूशन हो गया है. मतलब अगर पाइपलाइन आर्किटेक्चर है तो 5th क्लॉक साइकिल में 3 इंस्ट्रक्शन एग्जीक्यूट हो जाता है. नॉन पाइपलाइन आर्किटेक्चर है तो 9 clock cycles लगा. This is right now what you are showing in seeing in front of you is a 3-stage pipeline. 3 stage क्या है? Fetch, decode and execute. समझो fetch, decode, execute और store करके एक स्टेज है, मतलब वो 4-stage pipeline हुआ. तो 5 stages है तो 5-stage pipeline होगा. So pipelining can be 2-stage, 3-stage, 4-stage, 5-stage, etc., etc. So if you increase the number of stages, again the performance of your system is increasing. Now if you consider Pentium, Pentium का 5-stage pipeline है. तो 5-stage pipeline है मतलब in a clock cycle how many instructions will be active?
5.
5 instructions, right? 5 instructions will be active. अगर आप Pentium 4 को consider करोगे, Pentium 4 का 20-stage pipeline है, तो कितने instructions active होंगे?
20.
हाँ, but it's not 20 in Pentium 4. Pentium 4 में Pentium 4 has this concept which is called as superscalar pipelining. सुना है आपने ये term? Superscalar pipelining. Superscalar Pentium 4 में there are instead of 2 pipes, instead of 1 pipe, there are 2 pipes. और दोनों ही pipe में, I'm talking about Pentium 1. Okay, in Pentium 1 there are 2 pipes and which are of 5 stages each. तो मतलब कितने instructions execute होंगे? Current will be active at a time. 2 pipes, 5 stages. At a time, how many instructions will be active?
10.
10 instructions. ऐसे ही Pentium 4 में it also uses superscalar architecture. वहाँ पे it's a 4-pipe architecture with 20 stages. तो मतलब कितने instructions active रहेगा एक time पे? 4 pipes ऐसे ये एक pipe है. 80 instructions are active at a time. Okay, so this architecture is also called as the net burst architecture. अगर आपने सुना होगा net Pentium 4 का net burst architecture, उसमें 4 pipes and 20 stages each. 4 पाइप मतलब ये एक पाइप है, ओके, दिस इज 1 पाइप. ऐसे ही 4 अलग पाइप, and each pipe is having 20 stages. So 4 into 20, 80 instructions are active at a time. Okay, this is what is meant by pipelining. So using pipelining, you are able to drastically improve the performance of your computer. See, अगर आप कार मैन्युफैक्चरिंग या कोई भी मैन्युफैक्चरिंग कंपनी का अगर मैन्युफैक्चरिंग प्रोसेस देखोगे, वो सब पाइपलाइन ही रहता है ना. अगर आपको एक कार मैन्युफैक्चर करना है तो those companies do not manufacture one car in 1 hour. They have this pipelined architecture. Pipelined architecture matlab they'll have stages and every car will be there in a different stage. So matlab after a certain time, the number of the output that is being produced or the number of cars which are coming out completely manufactured increases when they use pipelining in their manufacturing process. The same thing, it is the same thing which is being exploited inside your computer. So this concept where you exploit parallelism inside your computer is called as pipelining. So 8086 में कितना stage pipeline है? 8086 has 2-stage pipelining. 2-stage pipelining मतलब fetch and execute. Okay? तो ये decoding and execution एक साथ होता है, इसीलिए we are saying 8086 has 2-stage pipeline. So 8086 has 2-stage pipeline, Pentium 1 has 5-stage pipeline, Pentium 4 has 20-stage pipeline. As the number of stages increase, or as you increase the number of pipes, the performance of your computer, of your processor drastically increases. So this is one more very important feature of 8086, that 8086 uses the concept of pipelining, and it is a 2-stage pipeline that is being used. मतलब एक इंस्ट्रक्शन अगर एग्जीक्यूशन में है, एग्जीक्यूशन फेज में है, तो अगला इंस्ट्रक्शन कौन से फेज में रहेगा? फेच फेज में रहेगा. So thereby you are exploiting the property of parallelism inside a computer. Then the next feature is number of instructions inside a computer. In 8086 is instruction set. In the instruction set of 8086, you have 135 instructions with 8 8-bit registers and 8 16-bit registers. So we'll be discussing all these points in detail as we proceed. So remember, the instruction set of 8086 has 135 instructions, and there are 8 8-bit registers and 8 16-bit registers. Okay. So what are all the key features? 8086 has 40 pins, operates at 5 megahertz clock frequency. It is manufactured using high density metal oxide semiconductor technology. 8086 has 16-bit data bus. 16-bit data bus मतलब 8 clock cycle में 16 bits transfer हो सकते हैं. 8086 has 20-bit address bus. 20-bit address bus मतलब कितना memory access हो सकता है? 1 megabyte of memory. It has 1 megabyte memory location which is accessible. And then it implies that the address range will go from 00000H to FFFFH. Okay, H means hexadecimal. 8086 can operate in 2 modes, maximum and minimum. Minimum means it's a uniprocessor configuration. 8086 is the only processor in the system. Maximum mode means there are other co-processors working along with 8086 microprocessor. 8086 has 2-stage pipeline architecture, which is responsible for its increase in performance when you compare it with 8085. 8085 में pipelining का concept था ही नहीं. Then the instruction set of 8086 has 135 instructions. Power supply is +5 volt. 8086 microprocessor जो है वो +5 volt power supply पे काम करता है. Then another very important point is 8086 has this concept of memory banking. There are 2 memory banks in 8086. Okay, 2 banks. 2 banks मतलब you are able to access 16-bit parallelly, right? वो कैसे होता है? 8 bits in one bank, 8 bits in another bank. That is how you are able to access it, access 16 bits at a time in one clock cycle. So we'll be learning about memory banking in the coming sessions. This is another important aspect. 8086 has a concept which is called as memory segmentation. Another very important feature of 8086 is memory segmentation. Code segment, data segment, stack segment, extra segment. There are 4 segments. Whole memory is segmented into code segment, stack segment, data segment, and extra segment. So this point also we'll be learning in detail. Another important point, 8086 has 256 interrupts. It supports 256 interrupts. And the last point is 8086 has a 16-bit IO address. 16-bit IO address matlab it can support 2 power 16 IO ports. मतलब उतने devices आप connect कर सकते हो 8086 में. 2 power 16 is how much? 2 power 16 is 65536. You can connect these many input-output devices to 8086. That is the meaning of 16-bit IO address. So data bus कितना है? What is the size of 8086 data bus? What is the size of 8086 data bus? 16-bit. What is the size of the address bus?
20-bit.
20-bit. And what is the size of the input IO address? What is the size of the IO address?
2 raised to 16.
Okay. So these are all points or features which you have to keep in mind. This is normally asked for 5 marks, 5 or 8 marks. Explain the features of 8086. And these are the points that you're supposed to enlist. 40 pins hai, 16-bit data bus hai, 20-bit address bus hai, IO address का size 16-bit है, 2 मोड में ऑपरेट हो सकता है, मैक्सिमम मोड एंड मिनिमम मोड, 2-stage pipeline architecture hai. 8086 has the concept of memory banking. It has the concept of memory segmentation. It can support 256 interrupts. It has an instruction set with a size of 135 instructions. These are all the major points which you have to keep in mind regarding the features of 8086 microprocessor. Okay, so we'll wind up for the day. Are all these features clear to you? We'll be discussing all this memory banking, segmentation, interrupts, everything in detail in the coming sessions. Okay, all of them are individual topics in your syllabus. So right now we have just, it's just like a summary only. Is that clear, everybody?
Yes, ma'am.
Yes, ma'am.
Okay, just a minute. Let me take your attendance. Okay, I'll be considering this attendance which I'm taking through the collector only.